After Boyle, Gay-Lussac's, and Charles' law, there is actually the presence of the combined gas law. And now, whenever we're talking about the relationship that is present when it comes to the different variables mentioned here, we are now going to consider that in the case of combined gas law, that pressure and volume, they're indirectly proportional with each other, while temperature is directly proportional both to pressure and volume. That is the reason why we have this basic formula for pressure, volume, and temperature relationships. Basically, whenever we are going to consider now the different parts of our equation, we are now going to arrive with this base formula, which is T sub 1 times V sub 1 over T sub 1, which is also equivalent to T sub 2 times V sub 2 over T sub 2. Remember, pressure and volume, they are inversely proportional with each other, while pressure and temperature are directly proportional, and volume and temperature, it is directly proportional with each other. Okay, so now, how are we going to manipulate the different formula that is present in the combined gas law? Remember, our base formula, which is equivalent to P sub 1 times V sub 1 over T sub 1, is equivalent to P sub 2 times V sub 2 over T sub 2. The first thing that you will consider for you to get the different variables as quickly as possible is to do cross multiplication, in which it will now give you this alternative formula, which is equivalent to P sub 1 times V sub 1 times T sub 2, which is now equivalent to P sub 2 times V sub 2 times T sub 1. Okay, so this would be the alternative formula that we are going to use to manipulate these different types of variables. Now, for instance, we are looking for the formula for P sub 2, then the formula for V sub 1, and the formula for T sub 2. Okay, so how are we going to manipulate this formula? Okay, let's simply start with the presence of P sub 2. What would be the formula that we are going to use? So basically, since we have here P sub 2, we're going to divide both sides with V sub 2 and T sub 1 for us to eliminate these terms and to simply isolate the final pressure. Then, once we eliminated these terms, we are now going to arrive with the formula that is equivalent to P sub 1 times V sub 1 times T sub 2 over V sub 2 times T sub 1. Okay, so that would be our formula for P sub 2. In the case of V sub 1 still, we are going to consider here our base formula, our alternative base formula. And we are going to isolate V sub 1 by means of dividing both sides with P sub 1 and T sub 2. Okay, we're going to isolate V sub 1, which will simply give us the formula that is equivalent to P sub 2 times V sub 2 times T sub 1 over P sub 1 times T sub 2. Now, what would be the formula that we are going to use if we are looking for T sub 2? We are now going to isolate once again T sub 2, and we are going to divide both sides with P sub 1 and V sub 1. Then, cancel the terms in which will give us the formula that is equivalent to P sub 2, V sub 2, T sub 1 over T sub 1 times V sub 1. And now, let's consider this certain type of problem. According to this problem, consider a 25-liter gas in a container initially at 25 degrees Celsius at 1 atmosphere. If this gas is heated at 80 degrees Celsius, what will be the volume if the pressure is doubled? Okay, so now, let's consider this problem. Let's start with the given. The first thing that is mentioned here is our initial volume, which is equivalent now to 25 liters. Then, followed by initial temperature, which is now equivalent to 25 degrees Celsius. So once again, the unit that we are going to use here is in Kelvin, so we're going to convert 25 degrees Celsius plus 273.5, which will now give us 298.15 Kelvin. So this would be our initial temperature. And then, as mentioned here, the pressure is equivalent to 1 atmosphere. Then, the other part, if this gas is heated at 80 degrees, so it simply means that the final temperature or T sub 2 is equivalent to 80 degrees Celsius plus 273.15, which will give us 353.15 Kelvin, and it will now be equivalent to 2 atmospheres. Then, we are looking for the final volume. And when it comes to the combined gas law, for us to get the formula for V sub 2, we are now going to use here the alternative formula, which is P sub 1 times V sub 1 times T sub 2 is equivalent to V sub 2 times V sub 2 times T sub 1. Then we're going to isolate V sub 2 since we're going to divide both sides with P sub 2 and T sub 1. Which will now give us the formula that is equivalent to P sub 1 times V sub 1 times T sub 2 over P sub 2 over times T sub 1. So this would be the formula that we are going to utilize for this problem. For our solution, final volume is equivalent to P sub 1, which is 1 atmosphere, times initial volume, which is equivalent now to 25 liters. Then final temperature is equivalent to 353.15 Kelvin over our final pressure, which is 2 atmospheres. Then we're going to multiply this with the initial temperature of 298.15 Kelvin, which will simply give us now the answer for volume number 2, that is equivalent to 14.81 liters. Now the next one, after the combined gas law, we now have here the presence of the Avogadro's law. According to Amadeo Avogadro, it is simply observed that in this law, the relationship of the number of particles and the volume of gases in constant pressure and temperature. Avogadro postulated that equal volumes of gases at the same temperature and pressure contain the same number of particles. And for us to consider the representations of the different variables for this law, remember that the number of particles, it is represented by small letter n, and the volume, it is represented by capital letter V. And the relationship, it is directly proportional as well. So we could simply conclude that volume number 1, or initial volume, is directly proportional with the initial number of particles, in which if the volume increases, the number of particles will also increase. Okay, so this would be the base formula that we are going to utilize. Now, for instance, we are looking for the initial number. For us to get this, once again, we need to cross-multiply, in which we're going to use the alternate formula that is equivalent to V sub 1 times N sub 2 is equivalent to V sub 2 times N sub 1. So this would be our alternate formula for this. Then for us to isolate N sub 1, we are going to multiply both sides of our equation with V sub 2. Okay, which will now give us the formula that is equivalent to V sub 1 times N sub 2 over V sub 2. So basically, that is how we are going to manipulate this, just like how you manipulated Gay-Lussac's and even Charles' law. So once again, in the case of the Avogadro's law, we are just going to consider here the number of particles and volume. As mentioned, the initial number of particles, it is equivalent to 0.5 moles, while the volume, it is now equivalent to 12.2 liters. Then, the final number of particles, it is equivalent to 0.33 mole. And our required, it is now the final volume. Then, for us to get our equation for the final volume, we are now going to use the base formula, which is V sub 1 over N sub 1 is equivalent to V sub 2 over N sub 2. Then for us to isolate V sub 2, we are going to multiply both sides with N sub 2 over 1, N sub 2 over 1, in which it will now give us the formula of V sub 1 times N sub 2 over N sub 1. So this would be the formula that we are going to utilize for this problem. Then for our solution, V sub 2 is equivalent to V sub 1, which is 12.2 liters, times final number of particles, which is 0.33 moles, over initial number of particles, which is 0.5 moles. Now, our answer for the final volume, it will now be equivalent to the presence of 8.052 liters. That is now our final volume. Once again, as you can observe, since the number of particles decreases, the volume also decreases. And that is now the presence of the ideal gas law. Now, in the case of the ideal gas law, the three laws mentioned earlier shows the volume of a gas is dependent on pressure, temperature, and number of moles of gas present, and can be determined and combined as the following. Okay? Whenever we're talking about these three laws, it simply means the presence of the Boyle's law, the Charles law, and the Avogadro's law. Okay? But once again, we should never forget the presence of Gay-Lussac's and combined gas law. Now, in the case of the ideal gas law, we are now using here the formula, which is volume is equivalent to R, or the constant value, which is now will be multiplied with temperature, number of particles, over pressure. Or, the alternate formula that we can use this is PV is equivalent to nRT. Now, whenever we are talking about R, it is now equivalent to the constant value that's present among all ideal gases. And that constant value is equivalent to 0.0821 liters times atmospheres over mole times Kelvin. So this is now the unit and the value of R. Okay? Always remember that this is a constant value, 0.0821. This is the constant value of R that is present among all gas laws. Now, how are we going to manipulate this formula? It is pretty basic. We have PV is equivalent to nRT. Then, for instance, we are looking for the volume. Okay? For us to get the volume, we are now going to isolate volume on this side of the equation, which we are going to divide both sides with pressure, in which you're going to arrive with the formula nRT over P. Okay, so as simple as that. Now, for instance, you want to isolate the number of moles. Or you're just going to divide both sides with RT, or the constant and temperature, in which you're going to arrive with PV over RT. So that is actually basically how you are just going to manipulate the formula when it comes to the ideal gas law. And now, let's apply this in a problem. Now, according to this problem, what is the volume? So basically, it is now our required. Okay? What is the volume of a 2.3 mole of oxygen? Okay, that is our N, 2.3 mole, present in the tank at 2.3 atmospheres. That would be our pressure. 2.35 atmospheres at 32 degrees Celsius. That is now your temperature. Your temperature, which is equivalent to 32 degrees Celsius. Once again, you're going to add 273.15, which will give us which is now equivalent to 305.15 Kelvin. Okay, then other than this, once again, we have the constant value for the ideal gas, which is now equivalent on R, which is equivalent to 0.0821 liter times atmosphere over mole times Kelvin. Okay, so once again, whenever we're talking about constant value, it is always included here on ideal gas law. Now, for our equation, since we are looking for the volume, once again, we are going to use the base formula, which is PV is equivalent to nRT. Okay, we're going to isolate volume since we are now going to divide both sides with pressure. Okay, which will give us the formula of nRT over P. So this would be the formula that we are going to utilize. Now, for our solution, volume is equivalent to N, which is 2.3 moles. Then R, 0.0821 liter atmosphere over mole times Kelvin. Then temperature, it is 305.15 Kelvin over pressure, which is 2.35 atmospheres. Okay? Then, which will give us the value of the volume, which is equivalent to 23.77 liters. Remember, whenever we're talking about the ideal gases, these are the different gases that will follow the Avogadro's constant. It will also follow Boyle's law, and it will also follow Charles' law. Those three basic laws are included when it comes to the ideal gas law. So now at the end of our discussion, let's now consider here once again the relationship of the different variables that are present on the different gas laws. Okay, so once again, just a guide for every single one of you. We have the presence of the Boyle's law, then the presence of Gay-Lussac's law, then the presence of Charles' law. Okay, the next one, the combined gas law. Then after the combined gas law, we have the Avogadro's law. After the Avogadro's law, we have the presence of the ideal gas law. Okay? So once again, what are the different things that are present on the Boyle's law? We have the presence of volume and pressure. Okay? And whenever we're talking about volume and pressure, they are inversely related with each other. Then for Gay-Lussac's law, it is now the presence of pressure and temperature in which they are directly proportional. Then for the combined gas, or for the Charles' law, it is now temperature and volume, which is, once again, they are directly proportional with each other. Then combined gas law, it is now the presence of pressure, volume, and temperature. Okay, in which the combined gas law will now follow the relationship that is present among the first three laws. Then in the case of the Avogadro's law, it is now the relationship between volume and the number of particles, in which they are directly proportional with each other. And lastly, for the ideal gas law, it is now the presence of pressure, volume, number of moles, and even temperature, in which it will now follow the following rules. The relationship on Avogadro's law, Charles' law, and Boyle's law. All of these relationships are now present among the ideal gas law. So technically, this is just the different things that you should remember when it comes to the different gas laws. And on our consultation period, we're going to have the application of the gas laws. So once again, I just discussed here how you're going to manipulate different formulas and how you are going to answer different problems related to the different gas laws, but its application will be included on our consultation period. Okay, so that's all for the meantime. Do not forget to answer the worksheets that is present on your module, and at the same time, the practice makes permanent part. See you on our consultation period. Goodbye.